In this video, we're going to talk about divisibility rules. And so I had done videos on factorizations and prime factorizations, and I could bust through the numbers pretty quick. And the question is, how did I do that? Do you have a calculator? Actually, no, I tend to shun calculators, only because they very typically, for the math that I need, they are incredibly slow. And I'm usually going to make mistakes with my fatty old thumbs putting in the numbers and the processes. So I have tips and tricks. And so here's some of the tips and tricks, and these are very well-known tips and tricks. So please don't think that these are like, oh, and Phil's some sort of math genius. No, actually, most of these were taught to me. So if you want to see proofs on this, if you look in Wikipedia and you go through, they will show you some nice, rigorous proofs as to why these things happen. The first few aren't really all that hard to prove, but a little bit beyond the scope of this video. I perhaps will make a video on the proof of why 3 is divisible, or why a number is divisible by 3. That's usually not too bad. Alright, so just taking a look at these. 2, a number is divisible by 2 if the last digit is divisible by 2. In other words, if the number is an even number. 3 if you add up all the digits. So let's take an example on number 3 here. Add up, 342. We want to see if 342 is divisible by 3. So we're going to add up 3 plus 4 plus 2 is 9, and that is divisible by 3. Consequently, the same exact method is used for 9, sometimes called the rule of nines. So if the sum of the digits is divisible by 9, the number is. If the sum of digits is divisible by 3, then the number is. So 342 is divisible by 3. The number 4. Now, we look at the number 4, the number 8. The number 16 deals with the last 4 digits. The powers of 2, 2, 4, 8, 16, 32, 64, 1, they increase the number of digits you have to check. But otherwise, it's done identical. So 4, if the last 2 digits are divisible by 4. So when you're looking at the number 124, the number 24 divided by 4 is equal to 6, and that is divisible, so 124 is divisible by 4. If you're looking for 8, let's see, 1,000, let's take 1,064. So you look at the last 3 digits. Are the last 3 digits divisible by 8? And 64 is divisible by 8, so then 1,064 is also. Incidentally, that is 125, and 8 is 133 times 8. So there's an example of how to use that. Okay, so now 5, if the last digit is 5 or 0, and that should say other than 0 itself, because that really doesn't count. It's not a natural number. 6, if the number is divisible by 2 and 3. And so if I pick just kind of a random number here, and I say random, but I'm going to build it on purpose, the number 246 is divisible by 6 because 6 is divisible by 2, and 2 plus 4 plus 6 is equal to 12, which is divisible by 3. Since it's divisible by 2 and 3, it is divisible by 6. An interesting question to pose then is, if a composite is made up of only 2 primes, does the divisibility rule apply to the combination of those 2 primes? I have no idea. It's just an interesting question that popped into my head. For the number 10, if the last digit is 0, that is divisible by 10. And please don't get this idea that these are it. There are many more. There's rules for 7, there's rules for 13, there's rules for 23. It's just that as these primes get larger and larger and larger, they become more and more difficult to do. And the idea behind this is to get a really quick, down and dirty thought as to whether or not this number is going to work, so that when we factor it right the first time. But if you're sitting there having to take this number and then subtract twice this other number and then keep trucking on that until you find out if it's, that's just not worth it. So by and large, here are the divisibility rules. I had forgotten 9, but 9 looks just like 3. Change that to a 9, change that to a 9, same. It's a beautiful thing. So let's just go ahead and take a look at a couple of numbers here. To work on this, let's see if, let's find all the numbers that 360, that divide 360. So list all numbers 1 through 10 that divide 360. Okay, well, it ends in a 0. Right there we know that 0 is even, and so 2 works, 5 works, and 10 works. 3 plus 6, now if we check the 9s, 3 plus 6 plus 0 equals 9. That tells us that 3 and 9 work. 60, as we look at the last 2 digits, that is equal to 4 times 15, and that means that since 4 divides 60, it also divides 360, so 4 works. Now here's the trick, 8. Does 8 work? Well, we're just kind of divide it and see if it works. That's kind of the bad thing about it. So we put 8 into 360, and we say that, well, this goes in there 4 times for a total of 32, and that's 4, bring that down as 5. So yeah, it does, because this is 40, and then our remainder is 0. So 8 works. Sometimes the divisibility rules fail. Yeah, with a 3-digit number, you're just going to have to check 8. All right, so we found that happens. We found 2, 3, 4. So we have found 2, 3, 4, 5. Now, 2 and 3, and so 6, and 8, and 9, and 10. And look at that. In a minute, in less than a minute, we've found that 360 is divisible by all of these numbers. Now, those aren't the only numbers that it's divisible by. It's also probably divisible by 12. Well, it is divisible by 12. It's 12 and 30. But the idea here is that you get a lot of the numbers out of the way quickly, and it's just meant to guide you and help you.